Look, in Sanjoy Nath Geometrifying trigonometry systems, we construct the real numbers, and the real numbers are 2D triangles. And whenever we see any real number, then from the time of the Eudoxus days, from the time of Euclid, we know there is a reference line segment and there is a gluer line segment. Gluer line segment is also the output line segment. Suppose we have the two triangles here. Their three sides are A, D and C. If we want to represent a number that is a D by A, that means we know the reference line segment A here, and the D is another line segment, and the relationship between the D by A, D divided by A, means construction of these kind of triangles. D is larger than A or D is smaller than A. That can happen, and we can construct the triangles, and this right side is the stage of where we will show the gluing and the conditions of the gluing. Different kinds of gluing are there and different symmetries are there, and from there we will try to understand different kind of the symmetries that we can see on 2D plane, and ultimately from that we will reach towards the multi-possibility paths of the Feynman paths integral stage also. This is the way to do the reasoning about the quantum uncertainties, because the same numerical result hides lots of geometrical reality which are actually present inside the symmetries of the similarities of the triangles. In this video we will explain these kind of scenarios that we normally don't understand when we do whole arithmetic in a commutative properties style. Our reasoning system should change. We should not think in the commutative way everywhere, because geometry and the reality are not actually commutative. They always behave non-commutative. In this video we are talking about the multiplication is gluing with the real-time demonstration with the multiple configurations, and with those configurations we will discuss about the nature of arithmetic, the materialistic arithmetic behave in the probabilistic way, because several kind of geometric configuration are all true, equally valid and equally possible, and all of these geometric configurations share the same numerical result. This statement is a very powerful, important statement here, because when you see the 3 into 3 equal to 9, and there are 16 to the power 4, 64 varieties of the geometric configurations, and all are equally valid and equally possible, then it is overwhelming thing for reasoning. But that actually happens inside the world in reality, that people should understand in that direction. In Sanjoy Nath Geometrifying trigonometry, we expose this kind of reality through the simplest way of understanding about the multiplication is gluing. The constructions of the triangles are actually exposing the properties of the real numbers. Just a few moments back I talked that D by A is a relationship to construct the real number, where D is the length of this line segment, A is another length of the line segment. We could say it as a C by A, that could represent some other real number. We could say it as a C by D, that could represent another real number. We could say that it is a C by A, that could be another real number. In this way there are several configurations possible, and we will discuss on all those things in the separate videos. Now here we can take two real numbers. One is representing one triangle and another real number representing another triangle, and how these things are gluing. Now gluing means multiplication, and multiplication is gluing. we want to glue these two triangles, sometimes we will try to glue the D is glued with the R. Sometimes we will want to show you that how the D is glued with R and that will behave like this. Sometimes we will want to show you that this same triangle D is gluing with some other line segment of the second triangle. That means the construction of the similar triangles, the second triangles is glued over the first triangle, and we want to show the nature of this behavior of this gluing with the multiple symmetries on 2D Euclidean plane. This video will explain you to rethink about the entire arithmetic in the geometric way on the 2D Euclidean plane, such that you will understand the quantum reasoning of multi-possibilities are always present geometrically whenever we do any kind of arithmetic in our daily life, and our daily life commutative behaviors of the numbers hides several kind of reality that we have to understand, and this video is going to clarify this kind of misconceptions that people always think that 3 into 6 is equal to 6 into 3. No boss, that is not the reality. Reality behaves in a very different way. You don't have to learn quantum mechanics to understand this kind of deep reality. The simple Euclidean geometry is sufficient to give you this kind of reasoning potential. Now suppose we want to glue the second triangle over first triangle, and we can glue that in several ways. First triangle has 3 sides, second triangle has 3 sides, and any of these 3 sides can glue on the other, and in that way we can get different kind of gluing behaviors. Slowly and one after another we will try to explain you what kind of gluing is behaving in which way, for which symmetry, and when we will open up all the kinds of symmetries together, then it is going to show you a dance of Shiva of the nature, and that is a multi-possibility space where everything are possible and everything are valid, and on the 2D Euclidean plane, and from those so many kind of possibilities comes up, and which one is the right one, it is very tough to answer, and this theory of geometrifying trigonometry will answer which one to take when and which one not to take when. This is a very rich theory and which explains the entire calculus in a non-Newtonian way also. Now we will focus on the nature of the gluing and the behavior of the configurations, the behavior of the intersections, and behavior of the enclosing polygons that is forming due to the properties of the gluing. Suppose here we are talking about the configuration 1 gluing. The configuration 1 gluing means it is gluing one side of the second triangle is glued over the one side of the first triangle. You can see here easily that one side of the second triangle is exactly glued on the one side of the first triangle. When we open up the configuration 2, then we can see the mirror image of that previously glued object is also visible now. If we open up the configuration 3, then we can see the 180-degree rotation of the gluing rearrangement is also visible now. When we open up the option 4, then we can see the gluing behavior. The 4 types of gluing behavior on the same side are coming here. In this way, when we see the, if we don't show you the first 4 configurations, and if we want to show you only the second set of the 4 configurations of the multiplication, where the second side of the second triangle is glued over the first side of the first triangle, then the similar triangle, so second similarity, the similarity property holds for the second triangle, and which is constructed on the stage in the multiple glued forms, and then you can see the different other behavior. In the same way, if we open up all these 4 also, then we can see these behaviors are overlapping, but for some other theta these are not always overlapping. In this way, if we open up the other line segments glued and such that the second triangle is constructed, the similar triangle of the second triangle is constructed on the first triangle differently, then we can see a different kind of arrangements for the dynamics of these triangles. When the numbers changes, the geometric behaviors also changes. There is the first triangle represents the first number, second triangle represents the second number, and the behavior of the gluings shows us the different kind of behaviors here. In the same way, when the other side of the second triangle is glued with the first triangle's other side, then the behavior also open up with a different way, and the whole dance starts here, and multiple possibilities of the multiplications are visible now. In this way, if we open up all the options of multiplication, and then if we change the numbers, first triangle represents of course some number and second triangle represents some other numbers, then we can see that lots of intersections are also happening, lots of line segments are overlapping on each other, and this whole arrangement is the bunch of line segments which is called the balls objects in the geometrifying trigonometry. And these balls of line segments are constructed due to the varying natures of the properties of these triangles, and multiplication is gluing is visible in the dynamic sense here. Now if we want to find some more magic here, suppose if we want to show you the intersections here, and if we stop the line labels here, and then if we show only the intersections, and if we hide the line segments here, then you can see the magic of this dynamics. And in quantum mechanics also the things look puzzling, because so many possibilities and all are equally valid and equally possible, and then all the symmetries are seen together, and when two numbers are multiplied we see these kind of movements of the points which are intersections, that is the wave intersection kind of things also visible in the quantum mechanics. And then we feel confused because so many possibilities, so many valid possibilities all interact together, and then we see that these are nothing but the interaction behaviors of the multiple possibilities, and all the possibilities are equally valid and equally possible. And we don't take these things normally in our daily life, because we fool ourselves by considering that arithmetic is commutative. Actually arithmetic is not commutative. We have to treat everything as a non-commutative, and that is the point to think with these Sanjoy Nath calculus systems.